When we talk about nuclear energy, we immerse our minds in a world where science meets the frontier of innovation. This journey begins at the very heart of matter, where the most incredible forces are at work. We will explore the most revolutionary energy processes ever discovered: nuclear fission and fusion. These processes, which harness the energy locked in the nucleus of atoms, have the potential to meet our growing need for energy in ways that seemed impossible just a century ago. They are the key to understanding not only how the universe works, but also to unlocking new frontiers in the field of sustainable energy. Their understanding and application could mark a turning point in human history, offering solutions to some of the most pressing challenges of our time. Nuclear fission, which ushered in the age of atomic energy, remains at the heart of our ability to generate energy on a large scale. In this process, uranium or plutonium atoms are bombarded with neutrons, causing them to split and release enormous amounts of energy. This energy is captured in the form of heat, which is then transformed into electricity through a thermoelectric conversion process. However, fission also creates radioactive waste that requires careful management for thousands of years. Modern safety technologies and new reactor designs are making fission safer and more efficient. But nuclear waste remains a key challenge. Scientists continue to seek innovative ways to reduce and manage this waste, ensuring that nuclear energy is not only powerful but also responsible. Nuclear fusion, a process that powers stars, represents the holy grail of clean energy. It begins with the fusion of light atomic nuclei, typically hydrogen isotopes such as deuterium and tritium. When these nuclei are collided at very high temperatures, on the order of millions of degrees, they overcome their electrostatic repulsion and come together, forming a heavier nucleus. This union releases enormous amounts of energy, far more than is needed to trigger the initial reaction. Fusion does not produce long-term radioactive waste like fission, making it a particularly attractive energy option. However, achieving and maintaining the conditions necessary for fusion is a huge task. It requires extreme temperatures and pressures, similar to those found at the centers of stars. For fusion to occur, it is therefore essential to maintain an extremely hot and dense environment, a condition found in nature only in the hearts of stars. Researchers are exploring different methods to create and contain this superhot plasma in the laboratory, such as the use of powerful magnetic fields in tokamak reactors. Projects like ITER in southern France are exploring ways to contain the superhot plasma needed for fusion in a magnetic field. While fusion is still far from a practical reality for energy production, advances in this field could one day allow us to harness a nearly limitless and significantly cleaner source of energy. With each advance in fusion research, we move closer to an era where clean, abundant energy could become the norm, revolutionizing our approach to energy and contributing significantly to the fight against climate change. While fission is an established reality, fusion remains the focus of intense research. Next-generation nuclear power plants seek to improve the safety and efficiency of fission, while fusion research strives to transform the dream of clean and abundant energy. As we explore these two pillars of energy, we think about fundamental questions of physics, engineering, and environmental sustainability. Fission, with its legacy and challenges, and fusion, with its enormous potential, represent the two faces of energy nuclear. Both processes require in-depth understanding and careful management. Fission, already part of our energy mix, evolves towards greater safety and efficiency. Fusion, on the horizon, could one day provide us with virtually unlimited energy and more ecological. In conclusion, nuclear energy, whether through fission or fusion, remains an essential part of our search for sustainable energy solutions. Addressing current challenges and courageously pursuing new discoveries will lead humanity towards a brighter and cleaner future for our planet. Nuclear energy is not just a matter of science. It's a question of balance between the power we can wield and the responsibility that humanity must always bear. Thank you for accompanying us on this journey to discover nuclear energy. Remember, the future is in our hands. It's up to us to shape it with care and awareness. Please don't forget to subscribe to our channel. See you soon.